Okay, 2.1 vertex form of quadratic equations. We've done a lot of this already. It's kind of a review of it. I don't understand quite the order they do it in, but hopefully it will be much easier this time than it was the first time for you, because we worked on it quite a bit. So remember, a quadratic equation is f of x equals ax squared plus bx plus c. Okay, that is a quadratic equation where a is not 0, because if a was 0, it wouldn't be quadratic, it'd be linear, right? Because this whole thing would be 0. The quadratic parent function is just x squared. The shape is a parabola. And this is what it looks like right over here. And vertex form is plus or minus a x minus h squared plus k. Remember, h's and k's, lefts and rights. Mm-hmm. Okay, so basically, Carson, can you take your eye? Thank you. Appreciate it.
She's trying to find it.
Are you all down to at least vertex form?
I'm almost.
Tell me when you get to vertex form, because I'll switch the slide. Because it's on the next slide. City, are you good?
I'm getting there.
Are you writing every word?
Yes.
Don't do that.
I realize I would. That's making me look pretty.
She has to use highlighters too.
I'm switching.
I have to write down that formula.
That's why I said it's right here.
Okay.
Okay, vertex form. It's called vertex form because the vertex is in there. Yes? What variables are the vertex?
Didn't we do this?
Yes, we did. H and K. The vertex is H, K. Okay, so I've written down all these before for you. If A is greater than 0, that means it's positive. The graph goes up. That's why it's pointing to the plus and minus. If A is less than 0, the graph opens down because it's negative. If A, the absolute value of A, is greater than 1, the graph changes quicker than the parent function. So if it changes quicker, it goes narrower. If it is between 0 and 1, the graph changes slower than the parent function, making it wider. What happens if A equals 1? It's the same. It's the same as the parent function. Okay. H is the horizontal translation of the vertex, opposite direction of the sign. If it's negative, it goes right. If it's positive, it goes left. X equals H is the axis of symmetry. You will need to know that because you will have to identify this. If A is greater than 0, that means it opens up. Then H is a minimum. If A is less than 0, that means it opens down, and H is a maximum then. It's either the highest or lowest point. K is the vertical translation of the vertex. So this is everything you already had in your notes once, and we've already dealt with it quite a bit, I think. We spent quite a bit of time on it. Am I good? Okay. So These are just some examples. I have g of x equals negative 1/2 times x plus 2 squared. So the first thing, we just move left or right. What does the negative tell me?
That goes left,
No.
right,
The negative tells me it's going to go
down.
down. It's going to open down, yes?
Yeah.
The 1/2 tells me it's going to be wider.
Yeah.
And where's my vertex?
Um,
Negative 2.
If it's a fraction, it's wider. If it's a whole number, it's narrower.
Okay, if a is greater than 1, the graph is narrower. If a is between 0 and 1, which would make it a proper fraction. Do not say fraction because isn't 4/3 a fraction?
yep.
But is 4/3 greater than 1?
Yes.
Yep. So if it's between 0 and 1, then it's wider. Okay, so where's the vertex? Nope. What do we know about the h, guys?
It goes left 2.
It goes left 2, and so k is what?
The same. No.
K is 0. Well, yes, the same. And why is it 0? Because there's nothing back there, right? So it goes over here, and it goes down. Okay? Now, I will tell you, if we do an IXL or anything, you'll have to get another point to make it go that way. So you just pick another point, like right either side of the vertex. Makes it the easiest. Okay, the next one, I have 2, x minus 1 squared minus 3. So what's the 2 tell me?
It is narrower.
It opens up. We're going to always start with that. And then it is narrower. Vertex is where?
Negative 1, negative 3.
What's he forgetting about my h?
Be positive 1.
Positive 1, negative 3. So positive 1, negative 3 is my vertex. It opens up. They picked another point. If you pick 1, if you pick 2, you plug 2 in here. 2 minus 1 is 1. 1 squared is 1. 1 times 2 is 2. 2 minus 3 is negative 1. And it is symmetric, yes? Okay. The axis of symmetry is x equals h. Okay. Does it have a minimum or a maximum?
I don't remember what it is.
We'll look at the graph. Does it have a minimum or a maximum?
It has a minimum.
It has a minimum. It has a minimum at x equals 1. This h is really important because why?
It's the same.
It's the same. So the biggest thing you need to remember about the h is it's the opposite sign because the formula is negative h. So it will always be the opposite direction. So what you're doing today is basically this. Describe the transformation, then graph the function, identify the vertex, the axis of symmetry, minimum, maximum, domain, and range. Everything we've been doing, we did in chapter 1, the beginning of the year. So I have g of x equals negative x plus 2 squared. So we are going to go right across. You're going to say opens up or down, wider or narrower. What is the vertex? What is the axis of symmetry? What is the minimum, max, and domain and range? We're going to do it all. Okay, does it open up or down? Down. So it opens down. How did you know, Carson?
It's negative.
It's negative. Is it wider or narrower? Or the same?
It's the same.
It's the same. How do you know?
There's a 1 there.
There's a 1 there.
A 1.
Okay, what's the vertex?
Negative 2.
-2, comma,
0.
0. Okay, what's the axis of symmetry? X equals,
You just pick a random one.
no, axis of symmetry. What's the axis of symmetry?
H.
H.
It's -2. I think. Yeah.
So x equals -2. Min or max? Opens down. Do I have a minimum or a maximum?
Maximum.
A maximum at where?
-2, 0. I think.
Yes, because it happens to be that. And domain and range,
X and Y.
we'll graph it real quick before we do domain and range. Okay, so where's my vertex go?
-2 to 0.
-2, 0. A point on the side, let's use -1. So if I use -1 and plug it in, so -1 plus 2 is 1 squared is,
1.
and then you have a negative, so it's,
-1.
so the other point I have is -1, 1. -1, -1. And then it would also be -3, -1, wouldn't it? Because it's symmetrical.
Yep.
And then I draw my curve. If it tells you to draw the axis of symmetry, then what do? Put a little dotted line there, right? Okay. So what's my domain of this? It's a quadratic. Is there any limitations what I can put in there?
X would be
Is there any limitations what I can put in there? Nope. So x such that x is the set of all real numbers. You can write it like that, or you can write it what? -infinity to
okay.
positive infinity.
Makes sense now, 'cause it keeps going.
Okay. Range.
Be 0.
What do you mean 0?
Is 0 to infinity.
Range of the y's. What's the smallest y?
Infinity.
-infinity. Okay, so what's the biggest y?
It stops at 0.
It stops at 0, right? So y is less than equal to 0 as it goes down. And if I want to write it in interval notation, can it be equal to 0?
Yeah.
Yes. But you always start at the smallest. So -infinity to 0 and put a bracket. Either one of those you should be able to read.
Which one? What's the infinity one? What's it called?
That's interval notation. Okay, so the next one, g of x equals x minus 1 squared plus 2. Same thing. I want every single thing acknowledged. Up or down? How do you know?
Because there's no negative.
There's no negative. Wider or narrower or the same? Same. How do you know?
There's
Because what's in front of that? A 1. Where's the vertex? 1, 2. What's the axis of symmetry? X equals, you need to write it as x equals because it's a vertical line. You're writing an equation. Max or min? It opens up, guys. Max or min?
Minimum.
Minimum.
So if it opens down into math.
Yeah, because it, see the picture of it where it opens down?
Yeah.
Keep going up.
So if it opens up, it's a, where's the minimum at?
Yeah, 1, 0.
Nope.
-2. 1, 2.
1, 2. And you actually could write, and I think the book, like if you would do a math Excel, it would just say x equals 1. Okay, Domain, what is the domain on every single quadratic unless I put it into an application problem? What, Regan? Yeah, it's all real numbers. Unless I put it into an application problem, every single quadratic is all real numbers.
That's I double back R in it. Or L.
Double back R. Or negative infinity to positive infinity.
Oh.
Jenna, why aren't you taking notes?
Oh.
Okay? And let's try the range without looking at the picture.
Alright. Okay.
Because it's going to go up, yes? So this one over here was y was greater than, I'm sorry, less than equal to 0, right? And 0 was the y of the vertex, wasn't it?
2.
So am I greater than 2 or less than 2?
Greater than.
Greater than, because that's a minimum, yes? So if it's a minimum, it's going to be y is greater than or equal to 2.
How would you write it with the interval notation?
Well, what's the smallest then?
2.
No, if it's greater than, oh yeah, I'm sorry. Can it be 2?
Yeah.
Yes, it can be 2. It is 2. It's 1, 2, right? So it'd be 2. What's the biggest?
Infinity.
Infinity. Can I be infinity? Can I get to infinity?
Nope.
No.
Nope. So it is a parenthesis. And then graph it. Let's plug in 3. 3 minus 1 is 2, squared is 4, plus 2 is 6. So it's there, and then it's over. Same distance over there, yes? Now, this is a sketch. So, as long as I can see that you've marked your points, that you have that there, I'm good. Okay? I'm not giving you graph paper. If I give you graph paper, then you have to make it exactly right. And you don't want to do that, do you? Especially when it's like 32 and you just write a line and write 32. Oh, didn't make the axis of symmetry. And actually I did that wrong because it shouldn't go lower than that point, should it?
I was gonna say that looks a little.
There. And the axis of symmetry goes right through the what? That is really wonky.
Yeah.
There, that's better. Yours is good? Okay, so it says identify everything and graph it. Domain and range. Guess what the next one says?
Oh.
Write it. Ooh. You guys try this one on your own. You far enough I can start?
Just wait. I don't even have it written down again.
Aren't you putting in your notes?
I don't want it in my notes.
Okay.
Flip 2 pages too far. Alright, so it's down. I should be quiet. You don't know that.
Okay. So write the equation, and we have y equals ax minus h squared plus k. The y-intercept is -1. Okay. So, what do I have? The vertex. So what variable is that?
-2, 3.
Yeah, but what variable is -2?
Okay.
H and k. We also have something else. Y-intercept's a point, yes? What is that point? The y is -1. What is the x every single time? 0. So that would be what over in that equation?
A.
No.
I don't know.
What's the point?
X. 0.
X and Y. Yes?
Yep.
So I have Y, I have X, I have H, I have K, so I can solve for A, correct? And I need to solve for A. I can't just think it's going to be 1. It won't always be 1. So I just plug it in. So what's Y?
-1.
So -1 equals, we're solving for A. If it's negative, it will come out in the math here, okay? It will come out in the math. So then what's X?
0.
Minus,
Plus.
so minus a -2, so it turns to plus, correct?
Plus 2.
Squared, yes,
Squared.
plus 3. Okay, so I subtract the 3 over right away so I don't mess it up. So that gives me -4, yes?
Mhm.
So what's 0 plus 2 squared?
4.
4, so I have 4A, because it's times, correct? Because of the parentheses. So what's A?
-1.
-1 is A. So if A is -1 and my vertex is H and K, can I write this equation now?
Yeah.
So Y equals, what's A?
-1.
-1, and X is X, right? Then what's next?
Plus 2 squared.
Plus 2 squared
+3.
plus 3. So they have to give you a point, yes?
Yeah.
Now, they didn't give me a point, but they told me the y-intercept, so could I find the point? Yeah. If they say when x is 3, well, what do I have to do to get a y? Oh, I can't do it here. Never mind. Disregard that.
Oh.
Don't pay attention to that. Okay, questions on that? Okay, so you try. Write an equation of a parabola with a vertex of 1, -4, and passes through -2, -1. So you try it.
What is the passes through?
Like it goes, that's a point on the graph. Like the y-intercept, that was,
X and Y.
yep, the x and the y.
I was like paying attention, but I was thinking about something else. Like I was doing it right, and I like knew what I was doing. I just wasn't thinking about it. I was in my own state of mind.
Fill it in. So y equals ax minus h squared plus k. What's your y?
-2. No.
-1. We don't know a, right?
Uh-uh.
What's your x?
-2.
What's your k?
1. Well, H.
H is 1.
-1.
No.
Squared.
It'd be
Oh, okay, I get what you're
Yes,
saying.
huh?
Yeah,
-4.
-4.
Can you stop moving my table? Go on your own.
Shh. Quit jiggling your leg.
Yeah.
That's what she's trying to say.
Is Dylan botchered? Oh. It's okay, Dylan. Is that 9A?
Would be 130.
Well, no crap.
Wait 1 second. Hold your horses, Miss May.
No.
Oh my gosh, Carson, why do you not even have it solved?
I have it solved over here, but I want it in this one.
Okay, well, I'm.
That's not
Okay, so last example. Okay, so I said domain and range, domain was all real numbers unless you put it into an application problem, correct?
Correct.
Okay, so write an equation for the parabola. The height of a thrown ball is a quadratic function. We've talked about this before. Anytime I kick, throw any ball, is it going to be an upside down parabola?
Yeah.
Because it's going to go up and then back down because of gravity, yes? Now, it may not go really high up, but is it still going to go up? Yes. No matter how much we want to kick the soccer ball right across the ground, does it go right across the ground? No.
Yeah, I can't.
No matter how far much you want to do a straight throw in softball, it's not usually pretty straight. So gravity has an effect on it. So the parabola may look different, but it is always a parabola. The height of a thrown ball is a quadratic function of the time it has been in the air. The graph of a quadratic function is parabolic. I can't talk. Path of the ball. The vertex of the graph is 120, and the path of the ball includes the point 0,4. What is the expression that defines the function? Write the quadratic equation in vertex form and in y equals ax squared plus bx plus c, and state the domain and range.
Does that say that?
What did you just say?
What is vertex form?
What is vertex form, guys?
Is that the y equals a?
Yes.
Okay.
Okay, so we're going to start by doing vertex form. Did you just do it twice?
Yeah.
Do it again.
Aw. I actually can't. Shut up. I can
Okay,
smell it.
guys, people who listen to the video don't need to hear you. Work on the problem so we can have time to go through it.
Bro, you're so loud up there.
Because you get negative 16 for A.
Yeah.
Okay.
I'm like, I forget how to do simple. What are you talking about?
Okay. So now this is vertex form, yes? Okay. So in order,
Yeah. We did.
okay, and in order to get it in standard form, we need to multiply this out. So we need to take negative. So x minus 1 times x minus 1, because order of operations says I have to do that first, yes? Because it's squared. So I have to distribute it. So that would be x, so negative 16 times x squared minus 2x plus 1
Okay.
plus 20. And then what do I need to do? Distribute the negative 16. So negative 16x squared plus 32x minus 16 plus 20. So y equals negative 16x squared plus 32x plus 4. Okay, so this is standard form. How did we find it?
We did it.
We
X
just
minus one.
we just expanded this, yes?
Yeah.
Okay, squared means you take the quantity times itself, and you got to FOIL it out. Got to do it right. Now, I've got standard form and vertex form. I also want you to give me the domain and range. And the reason I'm asking you for the domain is because the domain is not all real numbers. Can I put negative time? Because that's what this is, time down here, yes? Can I put negative time? No. So I'm not going to be all real numbers. I'm going to be everything greater than what? 0. So x is greater than equal to 0.
What would it be in the other thing?
Well, what's the smallest?
0.
So can it be 0?
Yeah.
So bracket 0. And, oh, wait, it's not greater than equal to 0. I said it wrong. Look at the graph.
It's 4. Yep.
Nope.
What is
Nope. Domain is the x. 0 to what?
it? 0 to 2.
2. Why don't I want all this stuff? Can I go below the ground?
No.
No. So I want 0 as my smallest,
I mean, it could.
and my biggest is what?
2.
2.
So are they both being included?
Yep. So it'd be 0, comma 2. But my range, is my range going to change?
No,
Mm,
I don't know.
can I go negative feet?
No.
You can go back.
No.
You can't go.
Can I go negative feet?
No.
No. And where did I start?
Forward.
4. So it's going to go up to 20. And the smallest is what?
0.
0. So 0, can it be 0?
Yeah.
Yes. Can it be 20?
Uh-huh. That'd be 20.
Nope, 0, 20. Always smallest first. And that's why I wanted us to do the domain and range, because it's different when I put it into an application problem. Questions on this one?
No.
And
Our
I'm-
last example.
I think so. Let me check, but I'm pretty sure it is. Oh, there's one more. But is it the same?
Yeah.
Okay, so I want you guys to, I'm sure this is the last one.
No, it is.
Oh, it's the same.
Oh my gosh.
Wait a second. Oh, these just are words. Okay, try this one on your own.
I don't understand the what's it called? Standard form.
Okay, so get your vertex form. Do your vertex form. Start with that.
Alrighty.
Did you get negative 3 halves for your A?
Yeah.
Okay, so how am I going to get this into standard form? I have to multiply x minus 2 times what? X minus 2, because it says squared.
Wait, vertex.
So x squared minus 4x plus 4. And then I have to distribute what? 3 halves. So negative 3 halves x squared. Well, 3 halves times 4. 2 goes into 4 how many times? Twice. And 2 times 3 is, so plus 6x. And the next one's going to be minus 6. Because the same math is going to happen, right? Oh, it'd be,
Drop the 10 down.
yeah, it'd be 10 minus 6, which is what?
4.
4. I just didn't have enough room. So this is my standard form.
Okay.
Okay, so what is my domain?
Oh. Zero. Right.
Mm-hmm. Is less than equal to x, which is less than equal to.
4.5. Let's say. I think.
It's a little bit bigger than 4.5.
It's close. Probably like 4 point.
I technically would have to set this equal to 0, yes? To figure it out?
Can.
Let's do it. So we have 0. Can I subtract the 10 over right away?
Mm-hmm.
Okay, so negative 10 equals negative 3 halves x minus 2 squared. So if it's times negative, 3/2, I would have to put times negative 2/3, right?
Yeah.
So that would be 20/3 equals x minus 2 squared. How do I get rid of squared?
Uh,
Square root? Yes? So this is just x minus 2, so I'd add 2.
Yep.
So x would equal 2 plus, actually it's plus or minus, but we only want the plus because we want this end. The square root of 20 over 3. Now, do we know the square root of 20 over 3? No. But is that technically what that is?
Yeah.
Yeah. And it probably is like 4.6 or something like that. We'll put 4.6. But I just want you to notice that it's not all real numbers. Okay? What is my range? That one's easier. What is the y between?
0.
0 is my smallest. What's my biggest?
10.
10. These are ones where the range can be easier. Does it make more sense now, City, when you were doing the
Yeah.
standard form?
I understand the standard form.
Okay. Other questions on these? Okay, this one says write an equation, the transformation. This just doesn't give you the points. Are you going to do it any different?
No.
Where's my vertex?
0, 0.
Nope, where's my
Oh.
vertex? -1, 3. And what's a good point on that graph? Looks like this one.
7.
0, 4.
I think 0, 4 does. Would I do it any different than what we just did?
No.
No. Okay. Now this one, it says, what is the equation of F? Oh, of J? I don't know what that is.
I think
I don't know. Write the equation in vertex form and in standard form. If, it is J.
It is.
Let J be a quadratic function whose graph is translated 2 units to the right and 5 units down. So what does that make the vertex? 2 units to the right.
2,
Ooh.
5.
2, 5.
So it's 2, 5, right? Oh, 2 units down.
Negative.
Negative.
Okay. So you just put that on there. Does it say wider, narrower, or anything? No. So it'd just be y equals x minus 2 squared minus 5.
Yeah.
So you just do it. Okay? Okay. I want to ask you this question real quick. It says it's reflected across the x-axis. Wait a second. What does a parabola look like?
So it's like a U or.
If I reflected it across the x-axis, it wouldn't be going up. It would be going what?
Down.
Down. So it'd be negative a. And translated 1 unit down. And it just says 1 unit down. So the vertex is at 0 what? -1. So y equals negative x squared minus 1.
Sure.
It wouldn't be down from the regular vertex?
It is, but there's not, because it'd be x minus 0 squared.
Yeah, I know. I'm just saying.
Oh.
It wouldn't be 1 down from like the 2, -5.
No, it'd be from the it'd be from the regular one. So this last page is just what is in the book before you get to your homework assignment. So I always put that on there, but it's just everything that we already went through. So